Okay, good morning again, class. For this week, we're gonna start with electric potential. Tapos, next meeting, capacitors, something like that. Nakalagay sa study guide dun sa informal syllabus. Ganun. Tapos, okay, recall lang nung ginawa natin last meeting. So, last meeting, ano ba ginawa natin? Gauss's Law? Last week, Gauss's Law. Puro Gauss's Law lang tayo last week, di ba? Yung Monday, yung formal lesson, tapos Thursday, puro examples lang tayo. Okay. So, di ba, ang Gauss's Law, it works very easy. Ang dali nung formula, di ba? Kaso, ang problema, you need to have symmetry to be able to use Gauss's Law. So, pwede mo lang siya gamitin sa mga spherical, cylindrical, and planar objects. Kapag hindi na siya ganun, hindi mo na siya magagamit. So, yes, it makes our electric field calculations easier. Pero, ano siya, limited lang siya. Okay? So, we need to have more solving techniques for our electric field. And here comes our electric potential. Okay, electric potential is different from potential energy. Okay, so meron pa tayong electric potential energy. Discuss din natin yon. For now, titignan natin kung ano ba tong electric potential. Okay? Okay. Simula tayo kung sa electric field, nagsimula tayo sa electric field ng charge. Ganun din gagawin natin sa electric potential. Okay, by definition, the electric potential of a charge is given by this. Napakadali, no? Kasi magkakamukha yung mga equations nila. Yung sa electric field, ano yung itsura nun? 1 over 4 pi epsilon naught. Then Q over R squared. Use of force on Q0 must be equal to 1 over 4 pi epsilon naught Q0 R squared. Ito naman, ganito itsura niya. Okay? Bale, isa lang yung charge sa numerator, isa lang yung distance sa baba. And this quantity, the electric potential, is a scalar. Okay, so wala tayong problema ngayon sa directions kasi 'di ba yung electric field and forces meron silang direction. Sa electric potential, wala siyang direction, so that's one thing na mas madali sa kanya. Okay? Okay, and then if you have multiple charges, you would simply add them. Okay, so add mo yung contribution ng isa sa bawat isa. And then if meron kang continuous na charge distribution, it would look like this. Okay, 1 over 4 pi epsilon naught. Then you would have to integrate dq. Okay, so yung charge elements mo all over that distribution. Di ba yung last time, ang distributions natin, yung rod na paganyan. Tapos nasa x-axis. Hanapin mo raw yung electric field. Ito yung R. Ganyan. Okay, so ganyan itsura nyo, di ba? Okay, so ito distribution to ng charge. So ganun din dito, i-integrate mo lang siya. Since they all add normally. Okay. Okay, syempre, para matuto tayo, we have to start with examples. Okay? Try natin to. Try natin itong example natin na to. Pag multiple charges tayo, paano yan? Okay, so try. Meron tayong dipole here with Q1 and Q2 equal but opposite in charge. So 12 nanocoulomb for the Q1 and negative 12 nanocoulomb for the other one. Tapos 10 centimeter yung distance nila. Then we are tasked to calculate the electric potentials at points A, B, and C. Okay? Okay. So, try natin. Siyempre, dali lang naman to. Systematic lang tayo. At A, simulan natin sa A. So, dito yun. Dito yun sa point na yan. At this point, meron tayong dalawang mararamdaman na potential. Okay? So, the total potential at A should be given as V1, the potential due to Q1, plus V2, the potential due to Q2. Okay? And then we have V1 to be K times Q1 over R. Similarly, for V2, we have K Q2 over R. Pero, ang difference nila would be yung kung ano yung R. Okay? So, for V1, KQ1 must be over, tingnan natin. And ang distance ni Q1, KA, that's 6 centimeters. So, lilipat ka sa meters as usual para hindi magkagulo-gulo yung units. 0.06. And then for V2, we have KQ2. Ano yung distance niya? 4 centimeters, so that's 0.04 meters. Okay. Kailangan na lang natin mahanap yung KQ1, Q2. Okay? So, K is 9 times 10 to the 9th power. Tapos yung Q mo is Q1 would be 12 times 10 to the negative 9. Okay? Kasi nanocoulomb sila. So, nano times 10 to the negative 9 yun. Okay? So, madali lang i-multiply ito. Magka-cancel lang yung times 10 to the 9 at saka times 10 to the negative 9. Mumultiply mo na lang yung 9 times 12. So, that's 108. Okay. 108. Yung Q2 naman, di ba negative lang siya ng ng Q1. So, you just plug in the negative. Therefore, we have V1 to be 108 over 0.06. Then V2 would be negative 108, 0.04. Okay? Di pa ako naglalagay ng units kasi the electric potential has the units of volts. Ayun na lang. Doon ko na lang ipa-plug in yung units ko. So for V1, we have 1,800 volts. Taas, no? Then for V2, we have negative 2,700 volts. Then we add them to get the potential at 8. Okay, so walang dire-direction dito kaya siya mas madali. Don't have to think about that. Okay, for VA, we have, ano yung sagot ko? Sorry. 1.8 tsaka 2.7. Okay, so 1.8 minus 2.7. Okay. So this is negative 900 volts. Okay? So we are done with VA. Next, at B. So, nandito siya sa kabila. So, ang distances mo would be 4 and 14 centimeters, respectively. So, try natin at B. VB would be still the same. The contributions of the potentials from both charges. Then, things are a bit faster right now kasi alam mo na yung value ng K times Q1 tsaka K times Q2. which is 108. Okay, for V1, 108 over, ano siya kalayo? 4 centimeters, so that's 0.04. And then for V2, we have 108 negative 0.14. Kasi this is 10, then another 4. And yung total distance ni Q2 kay B. Okay? And I know this answer would be just 2,700 volts. And for the other one, I have, you may use your calculators as usual, negative 771.4285 volts. Okay. Then of course, i-add mo sila. Okay, so lagay ko na lang dito, pag pinagsama mo sila, ang lalabas na sagot ay 1928.5714 volts. Okay? Okay. At C, let's have a, at C, tingnan natin ano bang mangyayari. Okay, sa C naman, tingnan muna natin by intuition mo. Same distance yung Q1 at si Q2. Okay? So that can be, from that information alone, malalaman mo na pwedeng double sila or just zero. Okay? Kasi double, baka pwede pares lang sila ng contribution kasi same distance. Or magkaiba sila ng charge so that magka-cancel yung contributions nila. And we have the case of magka-cancel nga yung contribution nila. Kasi Q1 is positive, Q2 is negative, then their charges is the same, 12, negative 12, and their distance is the same, therefore the potential is the same, but opposite in signs. So, VC, dapat 0 makukuha natin, okay? So, V1 plus V2. V1, we already know to be 108 over 0.13 kasi 13 centimeters daw. 13 centimeters. So we have that. No need to calculate kasi tingnan na lang natin si V2. Negative 108 kasi negative yung charge niya. Then 0.13 din sa denominator. Okay? And from here, we can already see that V1 plus V2 is indeed 0. Okay? So tama intuition natin. Yeah. So that's your example right here. Okay? So let's try this example. So very similar to, no, kasi ginawa na natin to for the electric field. Now we're gonna get the electric potential. So mag-integrate tayo, pero huwag tayo matakot, no? Kasi pwede naman tayo mag-search sa internet ng integrals. Okay? So drawing lang muna natin. Wait, di pa nababasa. Okay, so meron daw tayong electric charge, capital Q, which is distributed uniformly along a line of length 2A. Okay, so between negative A and A. So equal parts lang sila. Okay, so ito ay A, ito ay negative A. So meron daw tayong charge Q here, distributed uniformly. Okay. And then we need to find the electric potential at point P on the x-axis at a distance x from the origin. Isipin nyo nasa ano to pala to. Nasa y-axis to, guys. Plus thin siya. Medyo pangit yung drawing ko. Baka mag-imply ng thickness. Eh. Okay, so P. Then, that's it. We need to, ano yung natin, yung formula natin? So 1 over 4 pi epsilon naught, integral ng dq over r. sorry. So V, the potential must be equal to 1 over 4 pi epsilon naught integral ng dq over r. So let's find r first. So kukuha ka ng element mo para may element ka dyan. Okay? Charge element, infinitesimal element, dq. Then that distance would be yan. So this is r. Tama? Kasi r would be the distance of the charge between the charge and the point in question, which is P. And that distance is simply the Pythagorean theorem, x squared plus y squared. Okay? We just need to find kung ano yung dq. Okay? So dq would be the small charge. And to find that, kailangan mo lang is malaman yung charge distribution. Charge density, I mean. Okay? So Q is distributed uniformly along 2A. So you know already that dq, color. Okay, ayaw niya magpapalit. Okay, so dq must be Q over 2A. So this is the smallest, So this first factor here is the smallest charge that you can get in this tube. Okay? In this, hindi pala tube to, rod line. Okay? So in this line, ang pinakamaliit na makukuha mo is Q over 2A. But your infinitesimal, yung size ng infinitesimal charge mo would be multiplying it with dy. Okay? Okay. So, para malaman mo kung tama ang ginagawa mo, no? You can always, dapat pag tinodo mo yung tinodo mo yung size ni dy, dapat makukuha mo yung total din sa kabila. Okay? So, ano yung total size ni dy? That would be 2a, di ba? So, pag pinlagin mo yung 2a dyan, makukuha mo q over 2a times 2a. Okay, you get the total charge. Okay, so which is the total lang din ng dq. So, ayun, para check lang kung tama ginagawa mo sa pagde-define ng dq. Okay? And then, from here, we just plug things in. 1 over 4 pi epsilon naught. Okay? And then, q over 2a. But we know that goes out of the integral. Then the denominator would be x squared plus y squared. Okay? So this is just 1 over 4 pi epsilon naught over 2a dy. Then you can look this up in the internet or whatever calculator do you have. Okay, so may mga integral calculator in the internet. You can use that. And then our y goes from negative a to a. Okay? So negative a yung boundaries ng y mo. Nung charge distribution mo. Okay, so you do this, makukuha mong result would be 1 over 4 pi epsilon naught. Then this would be logarithm square root ng x squared plus a squared plus a. Okay, so this is from a table of integrals. And this is it. Okay, with the unit volts. So yung units niya, pag mga ganito, nasa ano na yan. Nasa loob yung mga units niya. Okay, so no need to write volts here. Kasi these are all variables. Okay, so meters to, tapos charge to. So meron sila mga units sa loob ng variables nila. So no need to put the voltage sign here. Kailangan mo lang yung voltage sign kapag mga values yung ginagawa mo. Okay? Okay, so that's it for this example. And let's try another example. Ganun ulit, meron ding charge Q distributed uniformly around the thin ring of radius A. So drawing natin, no? So meron ka daw ring. Yan. At the center niya. Meron kang distance A na radius. Then we are asked to find the potential at point P on the ring axis at a distance x from the center of the ring. Okay, so hanapin mo lang daw dito. Gawa pa tayo ng isang coordinate system. Coordinate axis pala. Okay, so kunyari y. So this is your charge. Okay, so ring siya. And then, of course, this still, ito same pa rin. dq over r. First things first, hanapin mo yung r. Okay? So, yung r, kunin ko dito. Sipin nyo 3D, no? So, nandun siya sa likod. Ito yung nasa harap. Ito yung nasa harap, yun yung nasa likod. Okay? So, using your Pythagorean theorem again, so this is just x squared plus a squared. Okay? Malinaw naman yan, di ba? Tapos dq would be something like this. dq, kailangan mo makuha yung kanina, ito, q over 2a. For this case naman, yung ring mo, gano'n kahaba yun, that would be the circumference. So that is 2 pi a. Okay, so q over 2 pi a. Yung problema, no, paano yung kabilang term? So yung kabilang term mo would be finding the length of your infinitesimal charge. Okay, so yung charge na pag ganun. Okay? Okay, gandahan, i-zoom lang natin ito. Zoom natin. So, pag ganun yan. Okay, yan yung infinitesimal charge mo. Okay, paano mo kunin yan? So, sana alam nyo, no? Pero this is your, pag meron kang curved path, ang kailangan mo, di ba, para makuha yung arc length? Arc length. Okay, arc length would be, ibig sabihin tatlong equal sign, tatlong dash na symbol would be definition. Okay. So, it's equality pa rin siya, pero I'm starting to define things. I can define something like whatever I can. Pero pag equal sign na siya, definite na yung ano niya. Hindi siya ginawa by definition. Okay, so ayan, the definition ng arc length would be multiplying the radius of that arc times theta. Okay, kung gaano kalayo yung ano. So for this case, so meron kang ganyan. So may theta dito. Then kailangan mahanap kung gaano siya kalayo from the center. Okay, and that is given by a d theta. Okay? Okay. So, we have to check no kung tama pa yung pinaggagawa natin live. Okay. So, para ma-cover yung buong circle, you have to rotate your data or rotate your infinitesimal chunk here around this circle, around this ring. So that means that ano yung max value ni d theta? That would be 2 pi. Okay? So max value niya would be 2 pi. So we have q over 2 pi a times a, 2 pi. And this cancels out. Then we get the total charge. Okay? Tama yung ginawa natin in life. 1 over 4 pi epsilon. And then I plug my things in. 2 pi a d theta. Okay, pwede mo na i-cancel yung a actually, di ba? Pero, para lang malinaw. This is x squared plus a squared. Then, 0, 2 pi. Okay, so, lalabas lang yung denominator sa integral kasi we're integrating with respect to theta, but there's no theta everywhere. Walang theta, di ba? So, lalabas lang sila lahat. 1 over 4 pi epsilon naught. Then, x squared plus a squared. Q over Q over 2 pi. Tapos, kinancel ko na yung mga a. So, you're left with that. And this is 2 pi. So, this cancels out. You're left with this. 1 over 4 pi epsilon naught q over x squared plus a squared. Okay, so walang direction again dahil this is a potential. Okay, linaw. Okay, so actually you don't have to go to the trouble of doing that theta something. You can actually see it from the diagram itself, no? That okay, kahit gumalaw, umikot ka, mapapansin mo na si R doesn't change. Okay? Constant lang yung X niya. Di ba? So, kahit magpunta ka dito, kuwari at this point, okay. At this point, mapansin mo that this is still the same x squared, the same a squared. Okay, so R won't change as you go along this ring. And therefore, you can actually plug that out of here. Get that out of there. So, makuha mo talagang potential would be V must be equal to 1 over 4 pi epsilon naught. Then, I could factor out yung 1 over R dun sa integral. And I am left with this integral of dq. But what is the integral of dq? So, bububuin mo lang si dq, di ba? To build the whole thing. Ayun yung purpose ng integral, di ba? So, the integral of dq would just be the total charge. Q. Okay? And, ayun na. Ito na yung final answer. You just plug in R, which is a constant. Okay? Pero, ayan, to give you the mathematical satisfaction na it turns out, ayun din yun. Okay? Minsan kasi parang hocus-pocus pag sinabi ko lang na, ay, oo nga, no. Ganun lang pala yung gagawin. Okay? Pero ito may mathematical rigor. Para naman hindi ko kayo niloloko, di ba? Okay, so that's your potential. So, yung introduction ko for this lesson, di ba, something na pampadali siya dapat ng buhay natin. But parang additional ano lang siya. Additional effort lang siya. Hindi. Mapupunta rin tayo sa point natin. Okay? So now, kunwari, gusto kong pahirapan ng tao, no? Binigyan ka ng electric field, hanapin mo daw yung potential. Okay? De joke lang. Hindi yung pahirap sa buhay. Kasi, kung mapapansin mo, ano yung units ng potential natin? Volts, di ba? And saan mo naririnig yung volts? Di ba lagi yung sa mga saksakan natin? Okay. So, in the lab setup, ang electric potential, mahalaga siya. Kasi volts na siya agad. Which is yung mga nakukuha mo sa mga outlet mo. Okay? So, sometimes it's useful na makuha mo agad yung potential. Kunwari, given ka ng electric field. Okay? Pero in some setups na, kuwari kayo, biochem majors kayo, di ba? Na you have to know the motion of some molecule inside on the so malaman yung motion ng molecule mo kapag katabi siya ng something that produces electric fields. Okay? So from that, mas maganda ata na makuha mo agad muna yung potential saka mo makukuha yung field. Okay? So pupunta tayo dun sa point na yun, sa kabaliktaran nito. Okay? Finding the electric field from the electric potential. Kasi kapag tinitingnan mo na yung mga molecules mo, ang kailangan mo talaga is electric field to determine their motion kasi yung force would determine motion. Okay? So electric potential doesn't give you much information about its motion. Okay? All right. So ang formula to get the electric potential from the field is given by this. Okay? So tayo malula, no? Kasi ito ay yung left hand side would be electric potential difference. Okay? So yung sasaksakan natin, ito ay usually 220 volts. Tapos ito ay 0. Mini-measure siya with respect to 0 para mapadali buhay natin, di ba? Okay? So you have that. And then, the right-hand side would be the integral. Line integral ito. Sana na-discuss ito sa ibang math nyo. But simply, madali lang siya. Okay? So, in DL naman this part, DL, vector. So, naglalagay na naman tayo ng vector sa sa infinitesimal natin, unit ng integral natin. So, wag kayo matakot dyan. That would just be DL. Tapos, kung saan yung path niya. Okay? So, DL, L, hat. Okay? So, ayun. Multiplication lang siya ng direction ng line. Tapos yung haba ng line. Okay? Okay. Okay. Tapos, kapag si DL, hindi siya naka-align with your E, you have to consider the extra factor of cosine phi, which is the angle between those two vectors. Okay, so if you have vector A dotted with vector B, then if they're not aligned, they would be like this. Okay. Okay. So if they're parallel, cosine phi is just 1 kasi cosine 0. So AB na lang sila. Okay? Okay. Okay, so you have this. Try natin. Okay. Kuwari, given tayo ng electric field ng 4 pi epsilon naught. Ang isang charge, no? That's Q over R squared, or hat. Kuwari, given tayo yan, and we want to get the potential. Alam na natin yung potential, di ba? Kasi For a charge, alam na natin dapat this is 1 over 4 pi epsilon naught Q over R. Okay, alam na natin to. But what if we didn't know that? Ang alam lang natin would be this guy. Alam lang natin na ganito yung inscription nung given ka ng field para paano mo makukuha yung electric potential. Okay? So, dapat makukuha natin to in the end of our calculation. So, how do we do that? So, drawing muna natin kung ano yung itsura ng system natin. Meron kang charge. Okay, so the field goes radially outward. So, ito yung itsura ng electric field. As usual. Okay, so isipin nyo na lang pantay-patay yung linya ko. Kasi uniform yung electric field. Okay, pangit lang ako mag-drawing. As usual. Okay, so this is the electric field and we need to integrate it along a line. DL. So, syempre, hindi ka, wag mo na pahirapan sarili mo, no? Kuha ka na lang ng linyang parallel dun sa electric field mo. So, huwag ka na kumuha ng linyang pa ganyan para hindi ka mahirapan. Okay? So, kuha tayo ng linyang radially outward din. So, say random here. Okay? Para makuha kong ganyan. So, this is my DL. Or should I say DR na lang, di ba? Pwede naman. So, DR times R hat. Okay? So, kanina di ba sinabi ko parang DL, L hat. So, this time, since my path is yung radial line din. So, I would just change things up to DR, R hat. Okay? And then, if nalilito kayo, you can always change your coordinate system. You can rotate things. So, I could rotate this whole thing as like this. Sorry. Hindi ko ma-scroll. Okay. So, i-rotate ko to. So, ganun pa rin naman itsura niya. Naiilang kayo sa sa R notation. Okay. So, what can I do is I lie them down in the horizontal and just call this the x hat direction. Then I could, in this line, my electric field can be written as Ex 1 over 4 pi epsilon naught Q over x squared, x hat. Then my DL is the x direction, which is just x hat dx. Okay, para natural sa paningin nyo. You can always do that. So, nirotate lang natin siya ng clockwise ng onte. Okay? Okay. And then, we just need to know where to integrate from A to B. Okay? Ano yung A at ano yung B. So, one of them should be set as R. Okay? Set as R. Kasi ayun yung tinitignan mo. Titignan mo na lang ngayon kung ano yung isang variable mo. Kung saan mo siya ilalagay. Kung saan mo siya i-measure. Okay? So, ang potential mo, or ang electric field mo at least, is 1 over R squared. And then, what if I put R into infinity? So, E would become 0. So, that is useful for me. No? So, pwede kong gawin is that si A, piliin ko siya as R. Then si B as infinity. Okay? So, bakit si A ko pinili si R? Kasi siya yung positive dito siya yung positive dito sa dalawang terms, no? So, gusto ko i-drop out tong yung negative dito. So, pipiliin ko si B to be infinite. So, with that, VR, minus v infinity, which is just 0, must be equal to the integral of r to infinity, AB, yung electric field ko, which is 1 over 4 pi epsilon naught. Gamitin ko yung x para hindi tayo mahirapan. Same lang naman mangyayari. No? Same lang naman mangyayari. Okay ba lang sila ng pangalan? X lang to kanina. Kasi ito, r. Ganun pa rin naman yung integrate mo. Q over x squared, x hat, dotted with x hat dx. So x hat dotted with x hat, or any vector that is dot product with itself is 1. So this is 1, 1. Therefore, we're just integrating what are we integrating? Yun na lang. 1 over x squared dx. So we're just, in essence, ito lang in-integrate natin. Okay? Just lalabas lang ito mga constants mo. So, q over 4 pi epsilon naught. Ano yung integral ng 1 over x squared? So, dapat alam na natin, no? Pwede mo siya isulat as integral ng x negative 2 dx. And this is just, dadagdagan mo yung numerator, di-divide mo sa ano man lumabas. Okay, so that is negative 1 over x evaluated from r to infinity. And this is q over 4 pi epsilon naught. Okay, so sanay ako kasi isulat yung 4 pi epsilon naught, no? Kasi sa amin, pag nag-handle ka na ng electric field at magnetic field at the same time, it's nice to write them down para alam mo yung mga terms na electric field, alam mo yung terms na magnetic field. Okay, wala lang, share ko lang. Not useful for you. Pero pwede mo isulat as k, no? Okay, so going back, I just plug things in. Negative 1 over infinity minus over r. Okay? So this is 0. This is positive 1 over r. And this is just q over 4 pi epsilon naught 1 over r. Okay? Ito ba yung potential natin? Ito ba yung potential due to a point charge? Yes. Okay? So it checks out. Checks out. Okay, so paano naman kung baliktad yung nangyayari? Given ka ng electric potential, how do you get the electric field from there? Okay, so ganito siya. So yung electric field mo is just the negative ng partial derivatives ng potential mo. Okay? So yung I hat is just x hat, then j hat is just y hat, and z hat is just k hat. Okay? So same lang yan, in different notations lang. Okay? So ito yung formula niya. Okay? So what if sir, nasa R ka? Pupunta ka ba sa XYZ? Hindi na. Pag nasa R ka na, ganito yung itsura niya. Okay, simple, di ba? Ito yung itsura niya pag nasa R. Siyempre, meron ding kapag nasa spherical coordinates ka, this is actually mahirap yung niya, mahirap yung kapag nasa spherical ka, mahirap yung itsura niya. Kasi this is just your so, in essence, ganun pa rin naman yung itsura. Theta. Okay. Yung mga values ng E theta, E phi, they're very complicated. So, hindi siya mabibigay sa inyo in your lifetime as a biochem student. So, ito lang yung problemahin nyo. Okay? Ito lang. And that ER is given by this. Yung E theta is not partial of V, partial of theta. Hindi ganyan. May extra factors pa siya. Dahil kapag nagdi-deal ka with theta, you have to consider the arc lengths, etc., etc. Okay? So, FYI lang. FYI. So, important sa inyo, kapag R ginagamit, you have to use this. Then, if you want to turn it into a vector, you have to write it down like this. Okay, so baka malito pala kayo, sorry. Yung ER in this case ay positive. Positive yan. Okay, so nilabas ko lang yung negative. Mas maganda kasi tignan, sorry. So dito, may negative siya sa loob. So for this case, E must be R hat ER. Okay, in this case. Okay, anyway. Okay, so this is very tedious to write down. May ginawa yung mga mathematician natin to shorten that thing. So we have introduced the del symbol, the del operator. This is the del operator. Okay, so this whole thing na del is just this guy. To simplify the writing down. Okay. Then the final form would be the more general form of the electric field coming from the electric potential is given by this. Okay, so itong del operator, the derivative lang din naman siya, di ba? And madali mag-derivative as compared to integral. Okay, so the electric potential, by calculating the electric potential, you can easily get the electric field. Okay, kaya yung sinasabi ko na mas madali siya kasi walang directions. Mas madali din yung integral kasi hindi siya over r squared. Kasi wala nga siyang directions. Okay? Okay, so your electric field is just ang tawag dito gradient. Yung sa operation na yan, gradient. Okay, kasi meron ka pang other things na magagawa sa del operator mo. You can get the del operator, the dot product with some function f. Then you can get the cross product of some function f. Then you can actually have something like this. Like that. Okay, so this is called for your information. Hindi naman kailangan, hindi naman required sa exam. This is just the divergence. This is the curl. And this is the Laplacian. Named after Laplace. Okay. So wala lang. Fun fact. Fun. Okay. So that's how you get the electric field from the potential. Siyempre, we have to get some sanity checks. Okay, so hanapin naman natin yung potential, hanapin naman natin yung electric field from the potential. Kuwari, nalaman natin na V is equal to 1 over 4 pi epsilon naught Q over R. And we didn't know the electric field. Tapos nakita natin na, ganito pala mag-calculate ng electric field. Okay, so the E vector must be equal to R hat times the negative of the derivative of V with respect to R. So this is just negative 1 over 4 pi epsilon naught times Q. Okay, lagay natin Q doon. Tapos, the derivative of R, the derivative with respect to R ng 1 over R, then the direction R hat. Okay? So this is easier. Derivative ka ng 1 over R. So, derivative ng 1 over R, we should already know that. But, So, pwede mo isulat si 1 over r ng r negative 1. Tapos, ibababa mo yung negative 1. Tapos, babawasan mo na isa. Okay, so that's the derivative. So, there we have it. E must be equal to, may negative dito, may negative din dito. That would cancel out. Q over 4 pi epsilon naught. 1 over r squared, r hat. Okay, so derivative nito, negative 1 over r squared, cancels the negative, positive na siya. Then, plug that direction. So, this is the field. We already know this. Okay, so sanity check lang, sanity check. Okay. Okay, bilis ata natin. Anyway, we're now done with electric potential. We have more examples from the book. You can check that out. Kung masyadong mabilis yung ganap today. Okay. We then proceed to the electric potential energy. Okay. And how can we use this to get the electric potential? Okay. So, potential energy as usual. Okay. Kahit anong physics to, no? Kahit anong, ano yan. Ganito yung itsura ng energy. Okay. So, the work done from A to B by a conservative force must be yung difference lang nung potential energy mo at your initial state, then yung potential energy mo at your final state. Okay. Okay. So, ma-encounter nyo din to sa mga chem nyo. So, may mga exothermic processes kayo and mga ganun. Okay. So, kapag lumamig siya, dapat exothermic yun. Kasi you gave off heat. Something like that. Okay, so makikita nyo pa ulit yan somewhere in your life. Okay, but in general, this is the form of the potential energy. U is the potential energy. W is your work. Again, that is from A to B. Okay. So, pwede kang, kung sanay ka kasi mag-final minus initial, you can write this down as this. So, factor out mo lang negative. And work is just the negative of change in the potential energy. Potential energy. Okay? But we also know work to be the most simple definition of work would be the force you do along a distance d. Okay, so yung d mo would just be the distance from A to B. Distance A from A to B. And for a field, for a charge in a field, this work is just, kasi di ba meron ka, pag may charge ka na nasa loob ng electric field, you have this amount of force. And if gumalaw siya along that distance, B, then you have this work. Okay? QED. Okay, ano maganda dito? What is the potential energy kapag may item ka, di ba? Y. So this ball, this whatever this is, ano yung potential energy niyan? Sabihin natin potential energy dito at this point is 0. Okay? The potential energy for here is mgy. Okay? Kung naalala nyo pa, di ba? Yung mgy ay yung weight times yung height. So, ito yung hold niyang potential energy. And mapapansin nyo na very similar siya dito. Okay? So, yung D would be Y. And yung QE is the force. And here, the force is mg. Okay? So, ganun yung analogy dito. Okay? So, ayan. Okay. So between charges, the potential energy, okay, nasulat ko pala. Okay, the potential energy between charges is simply this. Okay, so between two charges, Q and Q naught, again, magkakamukha sila ng formula. Baka malito kayo or if it helps you, nice. If it confuses you, be wary. Be careful. You know? So U is given by this 1 over 4 pi epsilon naught Q, Q naught over R. Okay? Kakalito, no? Kasi magkakamukha talaga sila. So this is your potential energy. Okay, so may mga bagay ako na hindi na na-explain kung bakit sila ganyan. Kasi hindi naman kayo physics major and baka maubos lang yung oras niyo. Tapos hindi naman siya lumalabas sa exam. So sa exam, di ba, ang kailangan nyo kung paano mag-solve ng mga gantong bagay-bagay. So I'm doing that. I'm doing the calculation part para hindi kayo lost sa exam. Okay? But if ever you're very curious about some topics, you can always message me in Canvas. Or if there are topics na mabilis ako, you can always consult. You can always ask for a different way of explaining things. We can do that. I'm happy to do that. Okay? Baka kasi mamaya masyado ako mabilis kasi, you know, nasanay na ako sa mga physics majors na mabilis. So, but you're not physics major, so we have to do some changes. Okay? Okay ba yan? Okay, so you have to message lang kayo. Okay lang yan. I wouldn't mind. Okay, so let's gawin natin to. Okay, gawin natin to. Paano ba yan? Okay. Okay. So, meron tayong dalawang charges located at the x-axis. So, we have our x-axis. Then, at 0, A, 2A. Okay, so ayun yung mga coordinates mo. 0, A, 2A. Then, at 0 and A, meron kang Q1, Q2, tapos Q3. So, yan. So, you have two charges initially. Then, you are tasked to find the work that must be done by an external force to bring a third point charge, Q3, from infinity to x over 2a. Okay, and then find the potential energy of the system ng tatlong charges. Okay, so medyo parang paano yung letter A? Okay. So I must define things. Hindi ko siya define agad kanina kasi we need some context. Okay? So implied dito sa work done here is that yung work na nagde-define dito would be the conservative force, that is the force coming from the electric fields. Okay, so kapag yung electric field nagtulak siya ng charge from A to B, the work to do that is given by this formula. Okay? But if we are to move by an external force, kabila yung makukuha mong ano. Okay. Kabila yung makukuha mo. So, ano ibig ko sabihin nun? Sulat natin for the record. So, in WAV, or W from the work needed to move a charge from A to B, is given by AUA minus UB for sulat na lang natin para work done by E when moving A to B. Okay? So, kapag mayroon siyang ginalaw na charge from A to B, it does work by this amount. Okay? However, this same amount of force is the work done by an external force against E from B to A. Okay? Okay, so nakita niyo yung nakita niyo yung difference. So kanina A to B, B to A. Okay? So that same sila ng amount. Itong scenario na to, yung dalawang scenario na ito, same sila ng work na magagawa. Okay? So what if you want to get the work done by an external force kapag A to B? Therefore, you have to change the order of this. Maglalabas ka ng negative sign. Okay? So, in this case, okay. So, ano yung initial natin? A would be from infinity. So, A must be infinity. And B must be to A. Ay, nakalito pala, no? So, lagyan natin A prime. Okay. Yung A prime, dito. Okay, so therefore, the work needed by an external force, A prime B, must be equal to U B minus U to, A prime. Okay? Okay? So, binaliktad ko yung sign nila. Nagets ba kung bakit? Kasi external force tayo. Okay. So, this is just U to A minus U infinity. And U infinity, kapag pinlagyan mo infinity dito, automatically 0, di ba? 1 over infinity is 0. Therefore, we just need to calculate U over 2A. U 2A. Okay? So, the forces the potential energies that we can get at 2A. Not necessarily over 2A. Okay? Okay. So, at 2A, sino nakalagay doon? At 2A, nakalagay doon si third charge. UA is third charge. So, this is actually UA, U2A. Okay? And U3 is just yung sum ng energy from 1 and sum with 2. Okay? So, U13 would just be 1 over 4 pi epsilon naught. Q1, Q3. And then the distance of that 2 charges. Okay? So 1 and 3, ang distance nila, 2A. Okay? And then the other one, U2, 3, is just 1 over 4 pi epsilon naught. Q2, Q3. Then their distance would be 2A minus A, so that's A. Okay? And then, si Q1 lang yung negative. Okay? Si Q2, positive E. Si Q3, positive E din. Okay, so we have this guy to be negative E squared over 4 pi epsilon naught. Tapos, 1 over 2a. And then the other one would be e squared, 4 pi epsilon naught, 1 over a. And the sum, ang sum nila would be e squared over 4 pi epsilon naught a. Tapos, ang matitira would be negative 1/2 plus 1. Kuha ba? Pinagsama ko lang itong dalawa. Factor out a. Factor out 4 pi epsilon naught. Factor out e squared. So, for here, matitira negative 1/2, which is this. And the other one would be 1. So, yan. And this is simply positive 1/2. So, e squared, 8 pi epsilon naught. So, the work needed by an external force to bring a third charge from infinity to this point is given by this much. Okay? Okay. Okay, and then the next one would be finding the total potential energy of the system of 3 charges. So the total potential energy is simply U total would be the sum of, may tatlo kang charge, di ba? May tatlo kang combination, bale. So, meron kang combination ng 1, 3. Meron kang combination ng 2, 3. Meron kang combination ng 1, 2. Okay? So, mas problematic kapag mas marami. Kapag apat, mas marami ng mas marami ng combinations. Okay? So, to do this, we just write things down systematically. Gamitin natin K para hindi K. This is Q1, Q3. Then their distance would be 1 and 3, so 2A. Q2, 3 would be K. Q2, Q3, 2. Joke, K lang. And then the other one, 1, 2, is K, Q1, Q2. A lang din. Okay? And this is K, negative E squared. This is K, E squared, A. And this one is negative din kasi may Q1 siya. Negative E squared. Then you sum this 3. 1, 3 is 2A. Ba't nawala yung 2? Okay. So you sum this 3, lalabas si K, lalabas si E squared, lalabas si A. And then yung mga nasa loob, that would be negative 1/2, then plus 1. Okay. And then minus 1. 0. And then we're left with K over 2, E squared, A, or this is just 1, E squared over 8 pi epsilon naught A, positive. Okay? So, tingnan nyo, ito yung, there's something wrong. There's something wrong. Negative dapat. Okay. Very good, very good. Negative. Negative. Tama. Okay, may bonus ka dyan. Bonus. Okay, so thank you for correcting me. Papansin nyo, ito ay negative dahil, okay. So ito yung sinasabi ko kanina kung bakit tayo naglagay ng ganitong definition. Kapag gagawa ka ng external force, you calculate normally and then you just plug in your negative sign. Okay? Okay. Mapansin nyo rin na ito magkasing laki sila ng magnitude, di ba? But they were just, ang difference nila would be the signs. Di ko alam paano ma-explain sa inyo intuitively. Parang hindi siya pwedeng intuitively. Sir, bakit po naging negative? Hindi po ba positive dapat intuitively? Okay, the total charge is not positive. Kasi, ano ba natin explain? Ano explain? Okay. Sige, chat mo nga sa akin bakit siya intuitively positive. Sige, sige. Baka mas madali ba? Baka mas madali yung proof by counter example. Okay, so may tanong kasi sa atin na bakit daw negative yung huling Negative daw yung huling sagot natin. Yung total potential energy. Okay, sige. Tingin yung chat mo. May explanation dito may explanation. Okay. Positive naman yung Okay, so yung BI, total potential energy ng system of three charges. So, you're not bringing in a charge. You're not bringing in a charge. Okay? So, yung sa A, yung nagdadala ka ng charge doon sa system mo. At B, hindi ka na nagdadala ng charge. It's as if nandun silang tatlo lahat bigla. Okay? So, yung tama yung nasa naisip mo na pero that is for A. Okay? Sa unang tanong siya. Okay. So, ang explanation niya, guys, positive yung energy kasi mag-bring in ka ng work. Kasi this is positive, this is negative, and you're bringing in a positive charge. Okay? Therefore, dapat may positive yung work mo kasi ilalapit mo yung positive charge sa positive charge. Therefore, mas malapit sila. And from this definition, dapat makukuha mo positive. Okay? So, yung energy na yon, yung pagdadala mo sa kanya, kaya positive din dahil tinutulak siya papalayo ng charge Q2 mo. Okay? Okay, so yung a good thinking for potential energy is that yung mga charges mo, positive charges, gusto niya sa mas mababang energy. Okay? So mas mababang energy. So kapag merong U negative at some point at X, okay? Pupunta doon si Q. May tendency siyang pumunta doon. So nung binring up natin si third charge, Q3, nung binring up natin siya, ang makukuha nating energy is this. Ito yung effort na ginawa natin to overcome the repulsion of Q2. Okay? So, merong explanation dito si yung author, sila Young and Friedman, pero ayun. If you understand it that way, then okay, that's fine. So, basahin nyo, nasa libro. Okay. Okay. So, kasi dito sa A, ang unang tingin agad kasi natin dyan is, di ba, AB, WAB is UA minus UB. Tapos yung A mo, infinity. Tapos yung B mo would be bring it to 2A. So, ganito dapat yung unang natin. Kung titingnan lang natin via face value. Ito dapat yung natin. Pero, sinabi kasi sa atin na ano daw yung gagawin ng external force. Okay. So, nag-bring in tayo ng negative sign. Okay. Nag-bring in tayo ng negative sign dahil external force yung nag-exert ng effort. Okay? So, you may try more problems from your book to get a good grasp ng idea data. Okay? And then, as promised, anong kinalaman ng electric potential sa potential energy? You can write them down as this. So, you can actually get the potential B from the potential energy just by dividing it by Q, the charge in question. Pero ito actually yung mas gamit. Ito yung gamit. Okay? So, ano raw yung potential energy associated dun sa kanina example natin? So, ito yung examples natin. Kapag naglagay ka daw ng 4 nanocoulomb sa A, B, or C. Simply, magagawa natin to. So, meron kang tatlong energies, UA, UV, UC. At UA, 4 nanocoulomb, so that is 4 times 10 to the negative 9. So, just copy that. Ang magbabago lang would be the potential na minumultiply mo. So, ang potential na minumultiply natin would be, for the first part would be negative 900. Yung result natin kanina to. Tapos 1938.28. 1928. 2857. Then 0 for the third part. And if you do the calculations, this is just negative 3.6 times 10 to the negative 6 joules. And then 7.7 0 joules. Okay. So at yan sila. Okay, so kung i-map mo yung potential energy. So at this point sa gitna nila, 0 yung potential energy. Tapos as you go to the right, pa-negative siya ng pa-negative. So if you put a positive charge there sa A, it tends to go kung nasaan yung negative na lowest potential energy. Okay? And that is from the first session natin na yung positive charge attracted siya sa negative charges. Okay? Okay. So I think a better representation of energy for you guys, kayong mga biochem students, would be expressing joules in terms of electron volts. Kasi sanay kayo humawak ng electrons and whatsoever. Okay, so to transform joules into electron volts, you just have to divide them by the electronic charge E. So this is also equal to, kung di-divide mo siya by E, the charge E, so EI 1.602, the elementary charge. Oh no, times 10 to the negative 19. Tama ba? I have to search it para sure. Magnitude. Okay, so tama. 1.602 times 10 to the negative 19. You just have to write this down with blue. Okay, coulombs. Okay, so if you divide this number by that number, you'll actually get negative 22.47 times 10 to the 12, then 48.06 times 10 to the 12, then 0. This is electron volts. Okay? Okay, kung bakit to useful? So, maganda siyang basahin na you need this much amount of potential. Okay, so you need this 48.06 times 10 to the negative 12 volts to move your charge E. Ganun siya tignan. Okay, so ang laki ng value, no? Kasi tingnan nyo yung charge. 4 nanocoulomb. Sobrang laki ng 4 nanocoulomb charge, guys. Ha? So, mukha lang siya maliit, pero malaki yan. Kasi yung single charge mo, 1.602, times 10 to the negative 19 siya. Eh, yung mga ginagamit natin is times 10. Mga nanocoulomb times 10 to the negative 9. Times 10. Okay? So, ginagamit lang itong nanocoulomb para lang madali yung example natin. Kasi, di ba, K is in the order of times 10 to the 9th power. So, madali sila i-multiply. Kaya, ayun yung binibigay niyong example. Pero in real life, hindi ganito kalaki yung mga charges. Okay, sasabog yung ano mo niya, sasabog yung setup mo niyan. Okay? So, to go back from electron volts to joules, you just type this in your calculator. You get joules. Okay? So, you multiply it by E. Okay? Tapos baka magkamali kayo ng E, no? Dalawa yung E sa calculator. So, dapat yung gagamitin nyo na E yung ganito, yung electronic charge. Kasi meron ka ring value ng E, yung ganyan ng E, which is 2.718 something. Okay? Yung natural constant. Okay, anyway, I think we're done. So, for the asynchronous topic, you just read this. Ano ba yung equipotential surfaces? Okay? So, kung mapansin nyo dito, ano yung mga values na 0 yung potential din? So, at C, di ba, 0 yung potential natin. At any value, kuwari dito, same pa rin naman yung distance nung Q2 at Q1 dyan. So, this is 0 din. And if you, kung tutuloy mo siya, what happens is that you get, what did I do? Sorry. What happens is that you get a line wherein 0 lahat ng potential dyan. Okay? So, there are lines, there are surfaces, okay? So, equipotential lines, equipotential surfaces that meron silang equal potential. Okay? So, at this line, equal yung potential na 0 and many more. Okay? So, kung wari, for your radial charge. Okay, gawa tayo ng charge. Positive. Then, the electric field is denoted by green. Denoted by green. The equipotential surfaces would be a sphere surrounding your charge. Okay? Kasi ano yung potential? 1 over 4 pi epsilon naught Q over R. So, every point in R, okay, so R is equal to 1. So, lahat ng points that is 1 unit away from the center would have the same potential. Okay, so that is a sphere of potential. Equal potential sila. Okay? What else? Okay, I guess that's it for today. Okay, may mga nagre-request na pwede bang late mag-submit ng proud set. Sige, for now, for today's proud set, kung hindi kayo nakapag-submit you can send before 12 noon. Okay? 12 noon. Send nyo sa akin via email. Okay? Ang purpose kasi ng prob set is to prepare you for the next lesson. No? Sometimes, minsan kasi trip ko lang, bibigay akong bonus prob set. Itong mga bonus prob set, they're usually nice to know, pero baka hindi lumabas sa exam. And, ayan, bonus sila sa grade. Pero, yan, usually, ang purpose ng prob set is to prepare you for the next lesson. Okay? Kaya ako siya dine-deadline ng bago mag-start yung lesson. And again, my prob sets are not required. So, next time, hindi na ako tatanggap, okay? Kasi hindi naman siya required. Hindi mo kailangan gawin. Just for learning purposes siya. So, ayun. To do your prob sets, you must avoid procrastinating, cramming things. Okay. Pero kung di naman talaga kaya, hindi nyo kaya mapag-submit, that's okay. Hindi naman required. Okay? Again, para sila para matuto ka dun sa next lesson. So, after ng lesson, if may time kayo, gawin nyo na yung prob set. Madali lang naman yung prob sets na binibigay ko. And again, you can find the answers in the internet. You just have to explain it in your prob set. Kung bakit sila naging ganun systematically. Okay, so target date would be we are on the baka next 2 weeks. Next 2 weeks. Okay, next 2 weeks. Feel ko next 2 weeks. Hopefully. Okay, so yung sa mga hahabol, sige 12 noon by email ng prob set. Okay. Sa mga wala dito, pakisabi na lang sa kanila. Baka hindi ko pa ma-upload yung lesson natin agad-agad. Okay, so that's it.